Guys, if you are viewing my channel first time, please subscribe to my channel for more updates on embedded systems. Today we are mainly discussing about an introduction to 8051 assembly language. If I want to write this 8051 assembly language, first we need to know the architecture of 8051 microcontroller, and also we need to know some English keywords like mnemonics. Once we know the mnemonics and architecture of 8051, then we are able to write this 8051 assembly language very easily. Today we are going to learn step by step today about the assembly language. First one is 8051 instruction set. The 8051 instruction set can be divided into five subgroups. First one is data transfer. Here mainly if I want to move the data from one place to another place so that these many mnemonics can be used. Okay, next one is arithmetic, addition, subtraction, multiplication, division. For example, if I want to perform any arithmetic operations so that I can use these many mnemonics. Okay, next one is logic, and or XOR, not, and rotate operations. If I want to perform any logical operation, so that I can use these many mnemonics. Okay, next one is Boolean variable manipulations. Okay, here the mainly if I want to manipulate any particular register in a particular bit, so that I can use these many mnemonics, or we can directly we can manipulate any a bit addressable memory, so that I can use these many mnemonics. Okay, next one is program branching. Here the mainly conditional and unconditional jump instructions. For example, if I want to move our microcontroller control from one place to another place, so that I can use this branching mnemonics. Okay, if I want to write any assembly language, first we need to know these mnemonics. Okay, first one is data transfer. Okay, we'll discuss one by one mnemonic now. First one is move. For example, let us take one example, move a comma b. Okay, here the whatever the b content we are moving to a. Here the this mainly this mnemonic we are using to transfer the data from one register to another register, or one memory location to another memory locations. Mainly we are using this mnemonic for the data transfer. Okay, next one here, move c. For example, here move c is my code. If I want to move the data from code memory to my accumulator, so that I can use this move c. Next one is Movex. For example, if I want to move the data from external memory to the accumulator or some other register, so that I can use this Movex through the DPTR. Okay, next one is push or pop. Okay, mainly for the stack operations. If I want to push some data to the stack memory, so that I can use this instruction. If I want to pop or retrieve the data from the stack, so that I can use this pop instruction. Next, XCH. Okay, here the mainly exchange. Okay, if I want to exchange the content between the two registers, so that I can use this XCH. Okay, next XCHD. For example, if I want to exchange the content of only lower 4 bits between the registers, so that I can use this XCHD. Only the lower 4 bits can be exchanged between the registers. This is the mainly use of the mnemonic. Next one is arithmetic. Okay, here add. If I want to add the two registers content, so that I can use this ADD. Next, ADDC means add with carry. If I want to add the content of two registers plus a carry, so that I can use this ADDC. Next, sub B. Okay, here mainly for the subtraction we can use this one. If I want to subtract from the one register to another register, so that I can use this one. Next, increment with some register. For example, if I want to increment the content of register by one means, so that I can use this one. Okay, for example, if I want to decrement by one, so that I can use this mnemonic. Okay, next, mul. Let us take example mul AB. Okay, in case of multiplication, we can use this mnemonic. Okay, here the mainly if I want to multiply 8 bits, then I will get the result of 16 bits. Okay, first lower 8 bits I can move to the A register, and higher 8 bits I can move to the B register. These are mainly the multiplication operation. Okay, next one is div AB. For example, in case of division, whatever after the division my result or coefficient I am storing to the A register, and whatever the remainder I am storing to the B register. This is the operations of the division. Okay, next one, decimal adjust accumulator. For example, if I want to after the addition or subtraction, if I want to adjust my result, so that I can use this DAA. Okay, mainly if I want to follow my BCD code, binary coded decimal. For example, let us assume after the addition or subtraction, my result is 2a. Okay, for example, here decimal adjust always it will follows the binary coded decimal format. Okay, my 2a is not a binary coded decimal. Why? Because the second digit is a means greater than 9. Okay, if the every digit it will check, if it is greater than 9 it will add plus 6, then it will make always a bcd format, binary coded decimal. Always each and every digit should be 0 to 9. Okay, that way it will represent our accumulator. Okay, mainly we'll use of the decimal adjust. Okay, next we'll discuss more on the logical. If I want to perform logical AND, so that I can use A N L between the two registers. Next, OR logic, ORL is my OR logic. If I want to perform OR operation between the registers, so that I can use this one. Next, XRL, if I want to perform XOR operation between the registers, so that I can use this one. Next, clear, if I want to clear the register content completely with 0, so that I can use this clear. Next, complement, here this CPL is my complement. If I want to just complement from the 0 to 1, if I want to change the bit status, so that I can use this one. Zeros ones will be converted and ones will be zeros. Mainly it will complement the whatever the register content. Okay, next one is rotate left. Here the mainly rotate left means each and every bit will be shifted to the left. Okay, next here this D7 will be coming to the D0. This is the way mainly rotate left. Next to rotate left with carry. Let us assume here my carry is there. This carry will be moved to D0, D0, D1, D2, D3. This is the way complete shifting. Final D7 will be coming to the carry. This is a rotate left. Next to rotate right. Next, rotate right means here this D0 will be moved to D7. Next, D7 to D6. This is a rotate right. Next, rotate right with carry. Here, let us assume here we have one more carry. This D0 will be moved to the carry. This carry will be moved to D7. Again, D7 will be D6. This is the mainly rotate right with carry. Next is the swap. For example, if I want to do a swap between the lower nibble to higher nibble, this lower 4 bits will be moved to the higher 4 bits. Higher 4 bits will be moved to the lower 4 bits. This is a mainly swap operation will work. Okay, next we'll mainly discuss on the Boolean. If I want to perform any particular bit manipulation, so that I can use this many Boolean mnemonics. Next, clear. If I want to clear the particular bit, so that I can use this instruction. Next, set bit. If I want to particularly, I want to set this particular bit, so that I can use this one. Next, move. Here the mainly this move is the mainly for the byte operation. This is the mainly for the bit operations. If I want to move the content from one bit location to another bit locations, so that I can use this mnemonic. Okay, here the JC means jump if carry. Okay, if the carry is set to 1, then we are moving to another locations. Then otherwise we'll going to execute the next instruction. Next here the JNC, jump if no carry. For example, if the carry is not set, then we are going to another locations. If the carry is set, then we are going to execute the next locations. Here the JB means jump if the bit is set. Okay, for example, if my bit is set, then I am going to another locations. For example, if my bit is not set, we are going to the next locations. Here JNB means jump if bit not set. Okay, here bit not set means, for example, if my register bit is not set, then we are going to another locations. Otherwise, will be the next instruction to be executed. Okay, next here JBC. Here the will check whether the relative location, bit location, and also our register bit locations. If both locations are set to 1, then only we are moving to the other locations. Otherwise, will be the next instruction to be executed. Okay, here the ANL. If I want to do the AND operations between the two register bit contents, so that I can use this one. Okay, next one RL. If I want to apply the R operations between the two register bit content, so that I can use this one. Here the complement to the particular bit locations. If I want to do the complement, so that I can use this one. Okay, these are the mainly for the Boolean operations. Mainly if I want to manipulate the particular bit memory locations or the particular register bit location, so that I can use these many mnemonics. Okay, next one finally the branch instructions. Here the long jump. If I want to move my microcontroller control from one place to another place, so that mainly we can use these many branching instructions. This is a L jump means long jump. We can completely move the complete 64 kilobytes of memory. We can try to move from another place to another place by using this complete L jump. Here the absolute jump means within 2 KB we are able to move my microcontroller control to one place to another place within 2 KB. Here short jump means within 128 bytes of memory, so that we are able to move the my microcontroller control from one place to another place. For example, if my microcontroller control, if I want to move from one place to another place within 128 bytes, I can use this one. Within 2 KB, I can use this one. Within complete program memory or data memory, complete 64 kilobytes of memory, if I want to move my microcontroller control from one place to another place, so that I can use this one. Next here, jump if 0. Here I will check the register content. If the register content is 0, then I will going to other place. Otherwise, next instruction. Jump if not 0. Here I will check my register content is not 0. Then only I am going to execute the other locations, otherwise the next instruction. Here compare jump if not equal. Okay, here we'll check the two register contents are not equal, we are going to move to the another locations, otherwise the next instruction. Here decrement jump if not 0. Okay, here I will just decrement the register content. After the decrement we'll check whether the register content is 0 or not. If it is 0, not 0, only we are going to move to the another location. If it is 0, next locations. Okay, here the no operations. Here the L call also, we are going to move our microcontroller control from one place to another place. We can use this long call to complete 64 kilobytes of memory we can move. Here A call means absolute call. Mainly within this 2 KB, if I want to move my microcontroller control from one place to another place, so that I can use this one. Next here RET means written from the one of the function, so that I can use this one. Here RETA means written from interrupt, so that I can use this one. Next one is jump. Okay, finally, if I want to jump from one place to another place, I can use this one. Okay, mainly these are the branching instructions, these are the Boolean instructions, logical instructions, arithmetic, and data transfer. Mainly, if you know these many mnemonics, so that we can write our program very easily. And also, if you know the each and every functionality of this mnemonic, so that we can write our programming very easily. Okay, next we'll discuss more on here how we are going to write our assembly language. First is the label. For example, here we are using long call. Here I am mentioning some label, so that we are going to move to that particular label. Okay, here we need to write our mnemonic as we discussed so far, right? These mnemonics we are writing in the second location. And after that, destination and source. Okay, always destination is the first place, and the source is next place. Finally, we are writing the comments. This is the way we are writing each and every instruction in our assembly language. Okay, here already we discussed these three are optional. This should be mandatory. This we need to write RET is my mnemonic. Okay, this should be mandatory. The label, destination, and source is optional. Okay, next we'll discuss the addressing modes, the way of specifying our operands by using the operations, so that I can use this addressing modes. Here, first one is immediate addressing mode, register addressing mode, direct addressing mode, register indirect, indexed addressing mode. Okay, we will discuss these five addressing modes one by one now. Okay, first one is immediate addressing mode means whatever the we are using mainly hash. Hash means immediate data. Hash 10 means this is my immediate data. I am going to move to my A register content directly. Okay, next one is R0. I am moving hash 0A. Okay, here is source. Here is my destination always. Okay, if you see here the mnemonic and destination and source, this is my source. Okay, here move A comma hash 10 means direct immediate data I am moving to the A register directly. Next move R0 comma hash 0AH. Immediately this 0A I am moving to the R0 register. Okay, this is a hex format. H means hexadecimal value. If I am not mentioning anything, it will be decimal. Okay, here if you see the difference, okay, default will be the decimal 255. I am assigning to the R0. This is my decimal if I am not mentioning anything. For example, if my any digit is greater than 9, so that I am going to treat it as hexadecimal. For example, if 0 FFH means this is my hexadecimal, I am moving to the R0 directly. Okay, next last one is binary. If I want to move my binary data to the R0, so that I can write this way. Okay, any data we can move to our any register content. This is the immediately, so that I can use the immediate addressing mode. Okay, here the next one is register addressing mode. If I want to move the one register content to another register content, so that I can use the register addressing mode. Here the directly we are mentioning the register contents. Okay, directly one register to another registers. If I want to copy the data, so that I can use this addressing mode. Here the mainly we are using the A register R0 to R7 and DPTR. Okay, mainly we are using these many registers for our operations mainly. Okay, here this instruction should not be used. Move R0 comma R0. Okay, memory to memory we cannot move. Okay, if I want to move from R0 R1 to R0, first this R1 content I need to move to the A register. From A register I need to move to the R0 register. This is the way we need to write our program language. But here R1 to R0 we cannot move. This will get the assembly error. Okay, here mainly this is a mainly register addressing mode. If I want to move from one register to another register, this addressing mode we need to follow. Okay, next one is direct addressing mode. Here this is my 20H is my address. That is the address content I am moving to the accumulator. Here mainly whatever the here we have the internal data memory, RAM memory we have 128 bytes, 0 to 127 locations we have 0 to 7F in the hex format. Okay, this is a complete address range we can try to specify, and that register content we can directly move to the particular register. From the memory location to memory locations also we can follow this direct addressing mode. And also this also comes under to the direct addressing. Whatever the A register content I am also moving to the port 1. We this is also we have the addressing, right? E0 and port 1 means 90. Whatever the data we can move between the locations. Okay, here 20 means this is my address location. This address location content I am moving to the A register. This is a 40H, this address location content, and I'm moving to the 30H locations. Whatever the content of 40H locations, I'm moving to the 30H. Okay, this is a mainly if I want to work on the mainly direct addressing, so that I can use this one. Mainly direct addressing is the we need to mention our address source, and the destination can be a register or the address. Okay, these are mainly for the direct addressing mode. Okay, next indirect addressing mode we'll discuss here. First, if I want to load my 20H is my address I am loading to the R0. Okay, here at the rate R0, this address indirectly I am specifying 20H location. I have to move this 50H data to the 20H address location. This is the mainly indirect addressing mode. Okay, mainly we are using at the rate operator here. Okay, R0 is my I'm just assigning hash with immediate data. Okay, immediate 20H I'm assigning it here. I'm mentioning it as at the rate R0 means here the mainly indirect this will treat as address. This 20H address content will be moved to the this 50H. 50H is moved to the this 20H address indirectly. I'm using the indirect addressing mode. And this way also we can use move a comma at the rate R0. Okay, here the R0 indirect addressing mode, like 20H whatever the data content will be moved to the A. This is the indirect way we are specifying. Mainly in indirect addressing mode, mainly R0, R1 and DPTR. Mainly these three registers will be used for internal data accessing, so that we can use the indirect mentioning, so that I can use this R0 and R1. For example, for the external memory access, we can use this DPTR. If I want to point the external data memory, so that I can use this DPTR. If I want to read from the external memory or write to the external memory, mainly this DPTR will be used mainly in the indirect addressing mode. Similar way, this R0, R1, internal we have some data memory. If I want to read the content indirectly from the particular memory location, so that I can use this R0 and R1. Okay, last one is indexed addressing mode. Okay, here the mainly we are adding the two address contents. DPTR has some address content, plus I am adding my offset to the this DPTR. For example, let us assume this is my 1000 locations. If I want to access 1001 location, so that my offset is 1. Let us assume this 1001 location I am pointing indirectly in the code memory. Move C is my code memory. Whatever the code memory whatever I am pointing, that content will be moved to the accumulator. This is a mainly indexed addressing mode. If I want to access particular code memory location, that I want to move to the accumulator so that I can use this index addressing mode. Mainly here the DPTR or program counter can be used. Okay, thank you friends. Thank you for watching.